Mama don't like you and she likes everyone, and I never lied.
Tengo costa chorizo, Santa María, Tex-Mex, Shakira, nacho, salsa, sombrero, gato negro, mojito, Old El Paso, Madrid, Chihuahua.
The problem is a snowball melts so that the surface area decreases at a rate of 0.1 inches squared per minute. Calculate the rate of change of the volume when the radius is 12 inches.
But first,
some people are worth melting for. Just maybe not right this second. Hands down, this is the best day of my life, and quite possibly the last.
Oh, Olaf, hang on, little guy.
Oh. My own personal flurry!
Hello, it's me.
Now what I'm doing is drawing the snowball and the radius of it, which is given to us by the problem. So basically our problem is to calculate the rate of change of the volume when the radius is 12 inches.
That face though.
So what I'm doing here is writing down the formulas and data we have. First we have that our radius is 12 inches. Our volume formula is 4/3 of pi times r to the cube. And our area formula is 4 times pi times r squared.
We have to calculate the rate of change of the volume when the radius is 12 inches. The rate of change is negative, and because it is melting, and this is that every minute is dropping this quantity. We have the rate of change is this formula, and when substituting we have the negative result. Now we have to calculate the rate of change between the differential volume and the differential time.
Then we have our formula of the area. We're going to derivate it, and this is going to be the answer, and we are going to multiply it by the rate of change of the radius. And then we have the formula of the volume, and this also we derivated. This is the answer, and we multiply it by the rate of change of the radius. That is this one.
Now we're going to substitute the area formula. So it is negative because the ice of the snowball is melting. So we have negative, and it is 0.1 inches squared per minute melting. And this equals 8 pi times 12 inches but times Br over dt. So we need to isolate this, the differential of the radius over the differential of the time. So finally we get minus 0.1 inches squared per minute over 8 pi times 12 inches, and this is the rate of change of the radius. So finally we have that the answer, if we divide this, so the rate of change of the radius is minus 0.000331.
Okay. Then in our formula we only substitute the value of the rate of change of the radius, and this is our answer, the rate of change of the volume.
That can only mean one thing. Ever since I left the city, you